Alright, we have an old magnifier lamp of mine that's been broken for quite some time. It's dim and it flickers and it makes a unusual noise. Oh, it won't even turn on. There we go. You can kind of see it there. Quit that. Knowing that the power supply is really tiny in this, and with most LED drivers these days, they're pulse width modulated buck converters or boost converters. And let's get this cover off of here and see what we're looking at. Alright, here's the power supply. See if I can zoom in for y'all. Not too much. Yeah, not the greatest perspective. That's a little bit better. Alright, y'all can kind of see what's going on there. Plug it back in. Obviously the AC input's over here. So you have your fuse, transformer, here's your bridge rectifier. And y'all can't hear it probably, but there is a distinctive squeal likely coming from that PWM controller. And you generally want to do is most of these, what you call passive components, they're visually compromised whenever they go bad. But we'll have a quick see to see what the incoming voltage is after it comes out of that transformer. About 163, I don't know if y'all can see that or not. I'm gonna have to zoom out. Alright, so we got 163. These caps look good. Resistors, other various caps, diodes, the filtering cap. There's an optocoupler over here for feedback. And then your output. And you can kind of see a deviation. Looks like it runs directly into the switching transformer to isolate the primary from secondary power side. Basically separates the input from the output on the board. So let's see what's coming in on this thing. And it should be 2 and 3 if I can get in there without making sparks. So it's got 8 volts coming in. And output be over here. $161 out. Yep. And feedback is usually right next to it. $135 millivolts. And then your output, I might be able to zoom in so y'all can see what I'm talking about. Output, y'all kind of can't see it, but output, there's a negative and a positive, and it's going to be easiest to read it off of this the leg of this diode and the resistor. So it's given us 15.3, 15.2, which is obviously not enough if you only got half dimness. So I'm going to take this light ring off and see what it does unloaded. And quite a few screws here. Screws here. Quit rolling around. It's a little tight around this lens clamp. Another thing you want to do is check all the current resistors on the ring, because there'll be some about every so often on the ring itself. Hey, we got a connector. Zoom back out. Alright, looks like 75 ohms per. So 4.5. Looks like all of them are good. None of them have any visible damage. Yeah. They're all within tolerance. So what I can do now is hit it with the power supply. Or let's see what the peak output voltage is real quick. Plug this thing back in. And then we'll know what to put it to on the power supply. Of course, there's no load on it right now. But it still has a... You can still hear it sing a bit. Yeah, I can still hear it chopping away. 23? Yeah. Turn this back off. Get some test leads. And if y'all can see, it has markings for positive and negative. Alright, now we're just going to turn it on and see what the current draw is on the power supply. Let's see if I can get the angle out of this to visually see what the light ring is doing. I'm just going to barely put it in frame because it's probably going to get pretty bright. Do I not have one on there good? Oops. Duh, I got them on there backwards. Ooh, that's much brighter. Yeah, that's what it originally looked like. I don't even want to blind the camera with it. Yeah, you can see right there what it's doing. So, if we turn it down to 16 where it was, you can see how dull it is. And then it's drawing 37 milliamps. Looking for something I can angle that up, see if I can see a little better. Maybe. Yeah, it's probably about as good as it's going to get for y'all. Alright, so we're at 16 volts. Let's crank it up to peak output that we measured from the power supply itself. Alright, so 24 volts, and it's showing 736 milliamps. And we're going to want to write that down because chances are you won't be able to find this PWM controller anywhere. Because when they use these extremely Chinese components, there's never really any good crossover, and you're dang near searching the dark web trying to get a crossover for it. It appears my writing utensils have disappeared. Kind of happens when you got a kid running around. So we'll just write down 24 volts, 750 milliamp. And we'll need to know that to calculate out what the wattage is, which I think is gonna be 18 watts. So we'll need to make sure that it's an 18 watt controller, PWM controller. All right, let me turn this down because it's super bright. And now I can unplug this, and so basically what it seems like is either there's a problem in the feedback sense circuit for current and voltage, which it uses this, let me change that back, uses an optocoupler for the feedback, which is right down here, and we can check that because it uses, there's an LED on one side and a photo transistor on this side. So basically the LED creates light that activates the base on the transistor, and then it seeds the feedback voltage to the feedback line, which is probably pin 4 or 5, I believe. 4 or 5 on this controller here. And when we measured it, it was like 135 millivolts. So it was getting its feedback, so that tells me that the optocoupler is doing what it's supposed to. We can check it too anyways. You're checking to make sure that the transistor's not shorted and the diode is still working in one direction as it should. Now let me plug this back in, since that's not where the issue is. Come on, cheap ass thing. Gotta love it. These little connectors never want to line up. These barrel pins. There we go. I think it's going in. That doesn't feel right. Yeah, I feel like it's flattening the nose on one of them. Gotta love it. There it goes. Alright. Now let me just get this back in there. Alright, of course I turned back on, it's still doing the same thing. But let's see if I can get in here and give you a little better perspective. Of course it's a tight fit in there. get to it, because the input's going to be over here where the diode is. So if I can reach it, if not, I'll take the board out, which is probably what I'm going to have to do. I think what we're measuring is resistance, because these are in the circuit. Yeah, so that's why it's giving me readings like that. But since I already read, I was getting feedback of 133, 135 millivolts on that end. Chances are the main culprit is this little bugger here. Turn it back on. It's 15.2. And if I remember right, feedback was right here. 144. Yeah, 140 millivolts. Almost should have unplugged this to see what it changes to, but just audibly hearing it making its noise. Y'all can also get a, depending on how good your hearing is. And then we'll check the 2 and 3. Oh, backwards. So got 8 volts there. There we go. Yeah, and then no potential to ground, or to the analog ground, since there is no chassis ground on this. This is the CT leg, which is basically this capacitor right here. Oscillate capacitance, the timer. And then let's check the output again. 162 volts. Yep. Yeah, never hurts to see if any of these are loose. feedback cap, polyester. 170, 163, 9.4. But I do need to write down what the supply voltage is. 8. So VCC is supply voltage. And the output voltage. And then comes the fun task of trying to find one, and chances are it's going to be eBay or Amazon fresh off the boat from China. Chances are you're not going to find it. Alright. To be continued if I find parts and get it ordered. But just usually when these downclock themselves, because these operate usually around 30 kilohertz to 500 kilohertz, but when it becomes audible, you know it's clocking down, it's pulsing a lot slower than it's supposed to be because it's putting out a much lower voltage. So when it's supposed to be operating at 500 hertz, you're not going to hear it. You might, if you're hearing still good, you might hear it at 20K, but when it gets down to about 15, 17, you can start hearing these things. That's just a quick little video on how to troubleshoot these things. Hopefully it helps somebody. Now I'm going to try and see if I can find parts, because I looked earlier off camera and the part number on that didn't come back really to anything. It's a I don't even know if you're going to be able to see it. Yeah, it won't focus. Not in digital zoom, but it's a YZ203. So, I have to search the interwebs to try and find a crossover for it. Until then, will be to be continued.